No kidding.
Oh man. So Brad said he's not gonna be able to come. A bunch of stuff like came up. I guess that he's got to get done before work. When he works again tonight.
That
So
stinks.
I know. So I told him to text us if he needed help on anything. But this section was pretty simple. So
Oh yeah, it was all right.
yeah.
I like already took the homework quiz and I was like, crap, maybe I don't know this as well as I do.
Oh
But
dang.
it's like I looked over again and I was like, oh, that was stupid. Oh, that was really stupid.
Oh
So
no.
yeah,
Well, how'd you
but
do on the
I'm on the
sorry,
what?
on the test?
I got a 40%.
Ouch.
Yeah,
I'm sorry.
and I can like look over it and like do all that stuff. So
Yeah. I'm sorry. That
see what
sucks.
I did wrong. Yeah, it's cool. It's pretty normal for this class for me to get like a 40% the first try.
Oh.
And then like the next time I like figure out what it really was asking and I do a little bit better. So
Yeah. Well, that's good.
I'm just glad that we can have retakes.
Yeah, for
So
sure.
yeah. All right. Well, do you want to take the homework thing?
Yeah, let's do it. Okay. So, number 3, in pie charts, why are the slices different sizes? Um, isn't it B?
Yeah, that's the best one I can see. Because the other ones are just kind of ridiculous.
Yeah, that makes sense.
Okay.
Okay.
Power bar charts and Pareto charts related.
I have no idea how you pronounce it.
They're the same thing, aren't they?
Yeah, but um, it's C though because
Oh
the
yeah, because it's the only difference is that they're ordered differently.
uh huh.
Yep.
Let's see. We conclude that P with the little triangle is normally distributed if n times P is greater than or equal to 10 and n times 1 minus P is greater than 10, greater than or equal to 10. Is P the true proportion or the same proportion? Isn't it the true proportion?
Uh-huh.
Okay.
And then N is the sample size.
Mm-hmm. Um, if P equals 1/4, what is the smallest n that satisfies the requirement?
This
Uh,
is one that I got wrong. I don't
oh,
understand.
let's see. What'd you put?
Like on the quiz thing, I like didn't understand it. I like made it into a decimal of like 0.8. So this would be like 0.25. And I was like, wait, what? I don't know.
Um, let's see. Well, because like in this one, you just have to see how many you would have to have for it to equal 10, right?
Uh-huh.
And 10.
Right.
So, um, 10 divided by 0.25. Oh, no, that's not how you do it. Um, yeah, no, that's how you do it. Yeah, so it'd be 40.
Because it's like 40 times 0.25 is like equal to 10.
Uh huh. Oh, wait. But then you
That's
have to.
kind of what I did on the homework, and it said it was wrong. So I was like,
Well, the thing is, I think then you have to check it against the second one
oh yeah.
because you'd have to make sure that that fits the second one. So it would be 40 times 0.75, right?
Uh huh.
Yeah. So that one satisfies it as well. So it should be
what's
40.
40 times 0.75? Oh yeah, because that's 30. Oh, okay. Ah, that's what I got wrong then. I get you.
Oh, okay. Perfect.
Wait, what's the smallest? Would the smallest be 30 then?
No, because 30 doesn't satisfy the first one. Because if you 30 times
Oh, it has to be
0.25, it
greater
doesn't.
than 10.
Yeah.
Okay.
So you have to check both. Does that make more sense now?
Uh-huh. Yeah.
Okay. Okay.
Got it.
Perfect.
Okay. Use the following information to answer questions 8 and 9. Suppose n is 24 and p is 0.4. What is the mean of p? So, wouldn't you just go like 0.4 divided by 24?
I actually thought it was just 0.4 because the p equals the p with the triangle over it for the mean. When you don't have any information. Let me double check though in the reading. I just remember reading that. Just pull up the reading again. Let's see. I kind of did most of this yesterday, so I'm like having to refresh it.
Right.
Let's see.
Because we don't know like an x value. And
Yeah.
that's what it says like p is normally.
Or p is the true population. Yeah, so your p. Yeah, so the mean of the p with the triangle over it is still equal to p.
0.4.
Yeah.
Okay. Trust you.
I swear it's in the reading.
Okay. So then it says, what's the standard deviation of that? So it means that
So, yeah.
square root of 4 times 4.
Did you get 0.1?
Hold up.
Sorry.
Divided by 4. Yeah, I got 0.1.
Sweet.
Do you have to go like 0.100?
She didn't say that at all in this one.
Okay.
So I don't know. I'm just gonna leave it at 0.1.
Yeah.
Okay, so use the following information to answer questions 10 through 13. This is a kind of long quiz. It's weird. So Brittany batting average is 0.300. We want to determine the probability she will get more than 35 hits in her next 100 at-bats. N equals 100, P equals 0.3. What is P with the triangle rounded to decimal places? Okay, trying to determine probability 135.
So does that mean that the P in this one is a 0.3 as well?
I don't think so. So I think the times that it is just equal to the P is when you don't have any other proportion value. And plus in this one, you're trying to compare that to her regular batting average. So this is for this sample.
Okay.
And versus like her whole career. So I think it'd be 35 divided by 100. So 0.35?
Yes.
Okay.
What is the standard deviation? So we're just doing that same thing that we did before?
But we use the true, so the 0.3, not the 0.35.
Right.
So
So the N is 100, right? Because that's the sample size.
Yeah. So we got
6.3 divided by 100. So I got 0.0458257.
Yep. Yeah.
Round to 3 decimal places. 0, 4.
Okay. And then what is the z-score? So we got...
So you just take that number, and that's now the bottom number, and you take the P with the little thing over it minus the normal P, and you divide that by the standard deviation, right?
Yep.
Okay, I'm starting to get this.
That's good. 4, 6. The 3 decimal places.
So I got 1.087.
Same.
Yay!
So what is the probability Brittany gets at least 35 in her next 100 at bat?
That is 0.277.
Because what did you do on that one? Did you do
Plug it into the probability app?
Okay, 1 second. Sorry, I'm going to pull it up.
Okay.
I forgot we're using that again. Let's see. Page. So it would just be the right one, right?
What is the probability Brittany gets at least 35?
Yeah, but it'd be 35 or more. Because that's how they asked the original question.
Right. That she gets better than.
Yeah. Because you wouldn't want any that are less because she wants at least 35.
So it would be 0.139. Okay, I get you.
Okay. So So if the true proportion of people who support a political candidate is P equals 0.52, and if N equals 2,000 people are surveyed, we want to determine the probability that the results of the survey will suggest the candidate is losing the election. What is the standard deviation of P, sample P?
I don't think I understand this one.
I don't either. 1 second. Let's read that again.
We want to determine the probability that the results of the survey will suggest that the candidate is losing. So they're just asking us to plug in the numbers to get the P tilde or something?
I don't know. I'm trying to think. Because you want... Okay, I want to determine the probability that the results will suggest the candidate is losing the election. I don't understand why they're asking us for the standard deviation. I guess it would just be 0.5, or like it'd be just whatever is less than 0.5, because 0.5 would suggest that it's right down the middle, 50-50. So if it was like 0.49, then it would be less than the 50%. But that doesn't quite... What is the standard deviation?
I think, do you just like plug it into the equation?
Which one? What? Sorry.
Like the standard deviation of like P with a thing over it? Because all you need is like the P value and the N.
Yeah, that's true. I just... But we don't have like this sample P, if that makes sense.
Mm-hmm.
I don't... Okay. I think we're just like overthinking it, but I'm not sure still how to figure it out. Okay. Maybe it just wants us to find this standard deviation, because then if you were to find the z-score,
You would need the P value, which we're gonna find out. Right?
yeah.
Just kidding.
Because like for it to be exactly 50%, the P would just end up being 0.50, right? That makes sense?
Yeah.
So if you were to just assume that that's the number you're aiming for, when you found your z-score, you would just do all the ones underneath it instead of like to the right. Does that make sense? Like on the normal probability of it? Because you just want all the stuff below it. But it doesn't really help you find the standard deviation, and that's what I don't get.
But it does help you get the z-score later.
Uh-huh.
So it'd just be like 0.499 would be like the P with the thing over it, right?
Yeah.
Because that would mean he's losing.
Yeah. Maybe for the first one, they just want you to find the standard deviation for the numbers that they give you. And then the second one...
You use 0.50?
Yeah. I think. Okay, like let's look at the rest of the questions, because like the next one is, what probability do you compute using the normal probability applet? What is the probability the survey results will show the candidate is losing even though the true p equals 0.52? So I think we just use the numbers they give us. Just solve for the numbers they want.
All right.
Yeah, because it's just saying, okay, yeah, we're just overthinking this. That's what it is. We're overthinking it because it says, want to determine the probability that the results of the survey, so that these numbers will suggest that the candidate is losing the election. So it just wants to show us the probability of it using these numbers, I think. That's my best guess. Because I think they just want to say, like, so this is the true ones, but even though based on these, like, what's the chances that he's actually going to lose? Does that make sense?
Okay. Yeah.
Okay, that's sorry. That's really confusing. Okay. So what is the standard deviation?
Someone watching a movie at your house?
Yeah, they're watching Harry Potter.
Oh, nice. I thought it was either Harry Potter or Lord of the Rings from the music.
Good choices. Okay, so what is our P again? It's 0.52.
Uh-huh.
So I got 0.011.
Hold up.
Okay, sorry.
Okay, so the standard deviation is 0.011.
Yeah,
Is that what you
that's what I
got?
got. Yeah.
Okay. Then what z-score should you use?
So for this one, I'm wondering for our sample P, like the P with the triangle, just has to be 0.50. You just like assume it's 0.50, because then everything underneath it would be the probability of the person losing, right?
Okay, that makes sense.
Okay. No, I divided by 0.11.
Oh, dang it.
Uh-oh. So I got,
Go ahead.
oh, I got negative 1.818.
Uh-huh.
Okay. Perfect. And then for 16, what probability do you compute using the normal probability applet? Wouldn't it be the second one?
What does this big Z represent?
I think that would just be like your like proportion number. So like the, I don't know, I'm trying to think how to explain this. I think
Sorry.
No, you're good. You're good. I'm just trying to make a better way to explain it. Basically, like on your normal probability test, it would just be like, so the big Z would be the P with like the triangle over it, and then the little z would just be like that number that you get out of the probability output. No, it'd be your z-score, sorry. So little z is your z-score, the one we just calculated in 15, and then the big Z, I think, is your, just is representing the, whatchamacallit, can't think of the words.
The probability?
Yeah, thanks, sorry. I think. That's what I'm hoping.
So your z-score would be higher than your probability.
Well, I think the z is just in there is just supposed to represent like on your normal probability test where it's just like it would just be like little p and then is greater than or equal to the z-score that you're using. I don't know if that helped anymore. It'd be like
I'm sorry.
No, you're fine. You're fine. So if we were trying to use that p from question 14 where it says p equals 0.52, so the p would go where the big Z is, and the 0.52 would go where the little z is. And then so if you're trying to say you'll want to look at everything that is lower than the 0.52, you would go with the second one. But if you wanted to look at everything that's greater than that 0.52, you would go with the first one.
Okay, and since we're trying to find out if he's losing, it would be less than.
Yes. I think. At least that's how I understand it.
So it's like the alligator wants the bigger one, which is the little z.
Yeah.
Okay.
Perfect.
Yeah, that's been helping me a lot.
That's good. Yeah, it's the only way I can ever remember.
Alright.
So last question. What is the probability the survey results will show the candidate is losing even though the true p equals 0.52? So then we go plug in our z-score.
So you just want what's below it.
Mm-hmm.
So it's 0.035.
I think so. Okay. You ready to try it?
Yep.
Okay.
Hey, not bad.
Close. Let's see. What did we miss? Oh.
What?
Huh.
But that's what we used to get 17.
Yeah. Unless it just wanted us to use
like a positive 1.818.
Oh, that could be it. Could be it just wanted us to use the positive one, or it wanted us to just use. No, that doesn't make sense either. So I don't know. I don't know what's going on.
I have no idea.
Whatever.
We did pretty good.
Yeah.
And now I understand a lot better.
That's good.
Yeah. So I'll have to go retake that homework quiz.
Oh, okay. Well, that's good though. At least you can do a retake. You know.
Yeah, I'm grateful for that.
Well, good luck. I'm gonna run off to another meeting, so.
All right, have fun.
Thanks. You too.
Okay. Bye.
Bye.